Hi everyone, thanks for coming. My name is Ray McClure. I have a little startup called Secret Feature, just doing interactive installations. And previously I was a Flash developer, and with kind of Flash fiddling away, I've gotten into JavaScript and C++. And but since I was a little kid, I've really been into synthesizers. My sister used to play the saxophone, and when she would have her lessons, I'd get to go to the music store with her. And while I was waiting, I'd play with the Moog synthesizers they had there. This is in the '80s. I'd look back and try to figure out what models I was playing with, but I have no idea. But I could just get lost, and I don't actually know how to play music, but just the idea you could turn knobs and be able to create soundscapes and create sounds was really awesome. And so I was always into doing stuff with the computers, and then I became an animator, and I started buying synthesizers so that I could make sounds for my animations. And pretty soon, when I had some extra money, I'd buy synthesizers, and I'd buy more synthesizers, and I've got a big room of synthesizers. And then I don't know, maybe in like 2001 or 2000, Native Instruments, I learned about Native Instruments Reactor, which is a program where you can, I always wanted a modular synthesizer. I've recently started getting the pieces to build something like a modular synthesizer, but a modular synthesizer is a synthesizer that is basically just the components, and it allows you to plug them into each other so as opposed to it being a synthesizer that is you purchase a synthesizer that has a keyboard, it has all the modules built into it, and makes one sound. With a patchable modular synthesizer, you can plug them in, and you can take one modular synthesizer and plug it into another, and you can get components from all these different manufacturers or build your own, and so the sound from a modular synthesizer is infinite. So I was always really interested in this, and when I learned about Native Instruments Reactor, I found out that this is an app that allows you to patch the synthesizer modules together yourself. It's an app that synthesizes them, and so you can take oscillators and you can take envelopes, and we'll get into those in a second about what those actually are. But basically, the traditional modules that make up a synthesizer, you could build your own, and you can do whatever with that. And then it has MIDI in, so you can take any kind of MIDI controller, like the MIDI fighter, and then you can make it do whatever you want. So I started building a synthesizer in Reactor. I did that for a long time, and recently, I'm back. Recently in JavaScript, they came out with a web audio API, and it's not implemented yet in all of the browsers. But one thing that's cool is that it's in the iOS devices, so you can make your own. So you can make your own synthesizer using the web audio API, and you can make it with a nice, not so tactile, but definitely something you can hold, and you can make your own UI to be able to create your own synthesizer and create your own experience. They mentioned the Animoog before in the last presentation, and I have a 1-year-old daughter, and when she was 5 months old, she was already picking up the iPad and playing with it. She could see that how it would swipe things. But when she started playing with the Animoog synthesizer, she was making music just because it's just about or making sound. And the only thing was that there's a lot of menus on it. So she would make sounds until she hit something, and then that would stop the music, and then I would have to go and reset it. Sometimes I couldn't figure out what she had done. So when I found out that so I knew about the web audio API, and when I found out that you could actually use it with iPad, I started making her a synthesizer. And I wanted to be able to show you that, but I'm going to see if I can do this. So this is just something really simple synthesizer, and it's got you can change the waveform. And then she would always like to drag things, so I created this cloud, and then that rains, and and so it's not. I have to admit the results were not as good as the Animoog. She was not quite as impressed with the depth of the Animoog. She really was wondering where all those features were, but well, version 2, yeah. So what I want to talk about today is how you make a synthesizer. So I started making this demo synth, and basically right here is a keyboard tied to its an oscillator. An oscillator is basically a waveform that is a single cycle waveform that is repeating over and over, and this is basically what creates sound. Well, all sound is created out of sine waves, and then using sine waves you can construct square waves, triangle waves, sawtooth. Those are the basic ones, and at least those are the ones they offered in the web audio API. So you can hear how the tone changes. That's a sine wave, square, saw, and triangle. So that's the basic. That's the basic component, and you can hear that when the sound just pressing. So what's happening here is that the sound is continually running, and in between there is a gain module that is set to 0, and then when I press, basically it's like a volume knob, and when I press a key, it takes that volume and puts it all the way up, and then when I let go, it drops back down. So it's just letting the sound go through. So the way you do this is you have the so this first line of code here is just basically how you initialize the web audio API, and creating audio context is it's kind of like the last step before it goes out to your speakers, and creating one of these is what you're going to pass to all your synthesizers to be able to create oscillators and create different components. And then I'm creating an instance of the synthesizer monosynth that I've created, and the keyboard is actually is this keyboard right here, and I'm passing a instance of it. Before it was actually just putting out events. I was just really frustrated because I couldn't figure out why the sound wasn't coming out, and it turns out that Apple has made this really cool feature where you have to send a note in a touch before actually in a callback from touching before the audio starts. So I had everything, and everything looked great, and I was like, why isn't it working? Because I didn't want to actually put the audio generation in the keyboard. I'd rather have the keyboard just be sending out events. So yeah, so now we have this little hack in there that kicks things off. Yeah. So that's all that's happening in the keyboard is it's just doing note on and off, and it's also doing slide. So you can slide and yeah. So that's that. And then the monosynth. This portamento value is the value of the sound. So you can hear it kind of, as opposed to just jumping from one sound to another. It's just traveling a little bit to that sound, sliding to that sound. To get an oscillator, that audio context that we passed in up here, just the audio context create oscillator. This turns it on. And one of the good/bad things about the web audio API is that the way that it works is every time you create a sound, you doesn't have note off. So it has note on and note off. So if you want to do something like a polyphonic synth, every time you hit it, you actually have to create a new synthesizer, a new oscillator, detach it, retach it. So note on just turns it on, and instead of turning it on and off every time, we'll just have it running, and then we're creating this gain here, setting its value to 0, connecting the oscillator to the gain, and connecting the gain to the audio destination, which is our speakers or whatever output is. Now when it gets a note on from hitting the keyboard that's passed into the monosynth, it gets a note, and actually this is sending out notes traditional like so that would just be like a C, and then I have a table of notes up here that matches the note to the frequency. So this basically just tells the oscillator to set the frequency to get a C. So by playing that, it plays the course. It changes then by the frequency, it's the way the oscillator actually changes its pitch. So the oscillator is running. It's a sine wave. the speed that it is running at is how you hear the change in the pitch. So it's just playing faster and slower. Okay, so let me show you the next one. So now I've added a filter. This is a low pass filter. So now we have three, and as well as resonance. So now what a filter is we're running the oscillator into a module that will allow you to select part of this, to cut out part of the sound, so a range of frequency, and the resonance will accentuate the part that remains. So say if you want to remove the high, like you can hear right now, the high range frequencies are removed, and then the mid range frequencies are accentuated by, and that effect is increased by when we turn up the resonance. And then changing the cutoff is how you, and you hear this sound in electronic music all the time. Maybe it's a little more subtle, but yeah. So the only change going on here is that I've added two sliders, and I've added event handlers for those, and then it's just what's happening is that it's telling the synth to set its frequency. And I needed to get a little help here because some of the math actually is a little odd for how you would figure out the values for this, but there it is. I'll show a slide at the end. I'll show the beginning, but all this code is I've released all on GitHub, so you can go and check it out and make your own synthesizers. And then the iPad crashes. It'll take pictures. Yeah.
It looks like trash.
How do you?
Just throw it out there.
On the iPad is
yeah, that should work. You gotta pull out the battery. I think you're done.
There it is. All right.
Just crack it.
So you'll notice that when I was playing it, the sound is basically just you're holding as you're holding the key, you can hear the sound. When you take it off, the sound turns off. So it's very choppy. It's just like on off. Which would the traditional way to make a sound that fades in or fades out or has some kind of dynamic motion to it is to use an envelope. And there's different types of envelope, but the most common is a attack, delay, sustain, release, known as ADSR envelope. So what I've added one more module that has 3 sliders, and now you hear that the sound fades in and out, or has some kind of motion to it. The attack, so I'm going to just have it like this, and that's kind of what we had before. And then by adding attack, we'll make it so that it fades in, and adding release will make it so that when I let go, that it fades away. And all that I'm using the envelope for right now is for the volume. What you could use it for is any value. So you could actually have the pitch changing, or based off this kind of timing. Now the way that this is done. So I've added these event handlers for attack, decay, sustain, and release. And in the synth, I created an array that just has four 4 values. And so, okay, so attack will fade it in. Decay, and then you have decay and sustain and release. So decay is once the attack goes up and it reaches its high point, then the decay is the amount of time that it'll go to the. So as you hold it, and you're holding it, there's a level that it reaches that as you're holding it that is its peak level, and that's the sustained value. That's a sustained level. And decay is the amount of time after it fades in, the amount of time that it takes for it to reach its full sound that it's going to stay at as you hold it. Then when you let go, then it goes in the release phase, and that's how long it takes to fade out.
That's purely volume.
That's just that's the way an AESR envelope works, and it's not just for volume, but that's the way that I'm applying it right now. For the purpose of discussion, I had to keep it limited, but it sounds really cool when you have that on, when you're adjusting the pitch. So basically, you could have the pitch go up as the sound the volume rises, or any variable. That's the cool thing about a traditional modular synthesizer, is that you're plugging an envelope into anything else, and the Web Audio API allows you basically to do that as well. So where before on the note on, we were just turning it on and off, we're now ramping to the value at a time. The audio context gives you really sample accurate timing. So so when you say now equals this audio context dot current time, that gives you the timing on that corresponds to all your audio playing, so that you can get really sample accurate. So you're not going to get any hiccups, and everything's going to, when you say to play a sound at this time, it plays not just at the right second or millisecond, but actually like in time at the sample. So yeah, so they also get all the values for the gain or frequency, give you these linear ramp, 2 value at time, or exponential ramp. So these will be like how you do like tweening. So if you want a sound to change over time, you can schedule a time. You can actually have it begin at some point in the future. So that's what we're doing here, is that we're saying this this first one is for the attack, and it's saying right now plus the attack time, send it to 1. So it'll go from 0 up to 1 over the amount of time that you specified in that slider and for attack. And then the next one is decay, and that looks at now plus what you had in the attack, and then its own value as well. And it's setting it to this is the sustain value. So it's saying set the level to whatever we have set at the sustain, and then for note off, it's ramping back down to the value 0. When you let the key off, we get a note off. That's what triggers this method. And so from the time that you lift up the key to whatever you have set as the release value, you want it to ramp back down to 0. So finally, we've added an LFO, one more section with 2 more sliders. LFO is a low frequency oscillator. It's exactly the same thing as the sound that as the oscillator that's creating our sound, but it's running at a much lower rate, and typically it's used for modulating other values. So what we're doing is we're having this LFO, which has the same, you can see it. So it has the same options, sign, it's the exact same thing, but the rate is running as opposed to a rate that is audible, it's running at what was something that is more of a control rate. So when you're hearing this, that's running at a really fast frequency. Now, this is going to do something like this. So what that's doing is it's modulating the frequency of our oscillator. So we're running another oscillator controlling the frequency of our sound, and it's changing the frequency based off the way we have selected. So that's sine, square, saw, and triangle. And you can run that right into audible values. So when you hear at the end, it starts going really fast. It sounds like it's actually changing the tone of the sound. And so that's a really cool thing about the web audio API, is that it runs so fast that these values are happening at a sample level. So it's optimized. If you're trying to do this with traditional JavaScript, we wouldn't be able to do it this fast. You wouldn't be able to have a frequency that's being updated to sound like that. And I chose that range. It actually would go way faster, all the way to the range of audio. And the LFO right now, I have it set to go into the pitch. And again, this control value could have been set into anything. So when you hear the filter changing, that actually could have we could run the LFO into that value as well, and then you would get the same pattern of the same pattern of sound. You would get at a different instead of supposed to being frequency, you would get it as the filter value or any value. So any of these sliders, whatever they're controlling, you could also send an audio value or a oscillator value or envelope into that as well. So to get the so what I've done is you can only have one value running into, for the web audio API, you can only have, so if I'm modulating the frequency, I also need these still to change the frequency. While this is changing while we have our LFO that's updating the frequency. Luckily, you have an option on an oscillator to use what's called detuning, which is a musical term for using the value of cents. Now, this is 1 octave, and every step is 200 cents. So 1,200 cents will be 1 octave. So by setting the value of the rate to be 1,200, when I'm sorry, the value on the oscillator, when I have it all the way up, you're getting the sound is rotating between 1 octave up and down. So the sound becomes it doesn't lose its musical quality by paying attention to the numbers that would correspond to the keys. It doesn't change its pitch, so it's still playing a C right now. Yeah. Yeah, so basically it's just about plugging different modules that you get from the web audio API into the different parameters that it offers. So this last one, I created the LFO. And again, I had to create a gain to control this because otherwise you would have the LFO would be updating the frequency, and we want to be able to have a knob to change the value. So that is another gain the same as we're doing the master. And then just by changing that value is mixing it in and out. And that's all. So if you download the code, you'll see that over the parts that in the mono synth that I'm basically adding pieces. And from here you could create your own modules and you could start to add on to this. I've already created a delay, many different. I have the one that I showed you before, if you notice I was hitting the keys, it's polyphonic, so I created a pool of voices so you can actually have multiple sounds. It's really endless, and they've really done a good job of making all the basic components, and it's still early.
How many limited those settings to like the other parts of, things like the compass or the, accelerometer and all that stuff?
I haven't yet. And yeah. But that having that kind of that's what I love about the iPad is that just having this ability to touch it in this way, but also to be able to turn it, or a compass would be if you're turning the sound, if you're turning around and the sound is changing. All these ideas are really awesome. Yeah. So
Ray, does the index contain the keyboard as well? The keyboard markup?
Yeah.
Everything?
Yeah. It's all there.
I'm gonna play.
Cool. So in the future, what's coming up next is right now on the desktop in Chrome, you have the audio input where you could basically run a mic or another synthesizer. Like if you have another sound source or any kind of audio that you could run into a computer, you could run into, you could process. Multi-channel audio, so you could build a synthesizer and some kind of cool interface as you're sitting at 5.1. You can have this sound flying all around. And then really cool web MIDI API, which is cool for being able to control the synthesizers, but also really cool for being able to create like generative animations that say if you have a whole bunch of synthesizers that are putting out MIDI data to control them, so you could do like I was saying, some kind of generative animation or something where a character is doing something, and as it does something, it's triggering different MIDI events to control different things. I'm really excited about that one. I've learned a lot. I've spent a lot of time looking at this on Sound all synth secrets. They give you a lot of different diagrams for synthesis, how you approach different problems. And if you create something like I created a delay with feedback, they give you the ability to delay, but they delay one sample. But then if you run that feedback back in and you get the sound of like what is of echo or a actual delay pedal, when you've created that yourself, it's pretty nice. I created this 909 kick from next line says search for block diagrams. So I searched for the block diagram for a 909, which basically shows you how all those sounds. A 909 is a famous Roland drum machine you hear on pretty much every house song or you've ever listened to. If it was done right, it's in there. And so those sounds. Each of those drum sounds has a diagram for how the sound is generated. So when I recreated that in Reactor, and I hit it, and I hear a clap or I hear a bass drum, and it sounds like it, it's really cool. Yeah. So that's it. Yeah. Any more questions? Yeah.